This is the second video segment for the homework to assignment number 15. Okay, solution to assignment number 15. Now, we are doing the third block of problems from the top, and it says use the half angle formula to do something. Now, that is this group of formulas, half angle formulas. Okay, so we're going to be using these guys. Okay, there is a similarity between these two, but the way we used this thing in the previous video segment was to reduce the power. And half angle formula, this second block, this block down here, all the way down, is a version of what you see on the in the middle on the left side. Okay, so let me start with number 17. Okay, number 17, it says, all right, use the half angle formula to use the exact value of sine of 15 degrees. Now, do not put this thing in your calculator, okay, because it says use the exact value, find the exact value. When you put it in your calculator, unless you're extremely lucky and for very limited angles, you're not going to get the exact value. Now you can always check your answer against what you get in calculator to make sure that you didn't make a serious mistake. Now, what is the half angle formula that we use to do this? For example, we can let me uh, let me write it here from that block that I showed you. So a sine of 15 is 30 over 2. And I know everything about sine of 30. So the formula that we're going to use is this equal to plus or minus and the square root of 1 minus cosine of u divided by 2. We can use this, and where u is 30 degrees. The only thing is that, of course, there's no problem. We can plug it in. Sine of 30 degrees over 15 over 2, which is exactly what we want, is plus or minus square root of 1 minus cosine of 30 degrees divided by 2. Or sine of 15 degrees equal to plus or minus square root. Now we know cosine of 30 is 1 minus root 3 over 2. No problem there. The whole thing divided by 2. No problem. Now the question is, should I use a plus or should I use a minus? Well, 15 degrees is in first quadrant. Therefore, the sign must be positive. So the answer is equal to plus square root 1 minus root 3 over 2 divided by 2. This is it. Stop right there. Now, I don't know how they write the answer in the book. It could be that they do one more step here and write this thing as 2 minus root 3 over 4. This is just basic arithmetic. If you want to try it out, if you cannot go from this line to that line, means that you have to practice your arithmetic more. Okay, so that's number 17. So let's go and do number 18. Number 18, same kind of problem. It says use the half angle formula to get the exact value for tangent of 15 degrees. All right, we check our appropriate formula. For example, we have this one, tangent u over 2, half angle formula. Check it out. It's going to go like that. It can be 1 minus cosine of u over sine of u, or equal to sine of u over 1 plus cos u. You can use either one of them. It really doesn't matter. So I'm going to use this one, where u is equal to 30 degrees. Okay? So tangent of 30 degrees over 2 is equal to 1 minus cosine of 30 degrees divided by sine of 30 degrees. And there's no algebraic sign to pick. Notice the other one had a plus or minus. I don't have a plus or minus here, so just that's okay. So tangent of 15 degrees, that's the thing that I wanted, equal to 1 minus root 3 over 2. That is cosine of 30 divided by 1/2. In all likelihood, if you look at the answer in the book, it looks like this, 2 minus root 3. Believe me, that is 2 minus root 3. Make sure you can get it. Arithmetic. Next one, number 19, same kind of thing. It says tangent of 22.5 degrees. And once again, let me write that formula that we did just a minute ago. We have tangent of u over 2 equal to, I'll use this one, 1 minus cosine of u over sine of u. Because remember, there were two versions of this or that. It doesn't matter. So we have u equal to 45 degrees, which we know everything about. So tangent of 45 degrees over 2, which is exactly what that angle is, equal to 1 minus cosine of 45 degrees divided by sine of 45 degrees. Now, so tangent of 22.5 equal to 1 minus root 2 over 2 divided by root 2 over 2. And probably if you looked at the answer in the back of the book, that's going to be it's going to be 2 minus root 2 over root 2. If you looked at the answer in the book, either it looks like that, okay, or it will look like this, root 2 minus 1. Both of these are the same thing. All right, let's do number 20. Sine of 75 degrees. And you are asked to use the formulas that you learned in this section, half angle formula. Otherwise, we could have done it as sine of 30 degrees plus 45 degrees. This is from the previous section, but they want you to use the half angle formula. So what I'm going to do is I'm going to look at this thing. This is sine of 150 degrees divided by 2, right? That's the same thing. And so we go to our formulas for half angle formulas. Sine of u over 2 equal to plus or minus square root of 1 minus cosine of u over 2, where u is equal to 150 degrees. Okay, so we have sine of 150 degrees over 2 equal to plus or minus square root of 1 minus cosine of 150 degrees divided by 2. Now, okay, so the question is, which one of these two algebraic sign do I take? Do I take this one or do I take that one? Well, just look, sine of 75 degrees. Sine of 75 degrees is 75 degrees in the first quadrant. Sine of it is positive, so this is plus square root of 1 minus cosine of 150 degrees over 2. And I hope you still remember, you should, that if you have 150 degrees, 150 degrees is something like that. Let me clean this up. Okay. 150 degrees, here's the trig circle. 150 degrees is something like this, right? So the reference angle for it is that, which is 30 degrees. This is the reference angle for it. And so the cosine of 150 degrees is negative of cosine of 30. So negative cosine of 30 degrees. And let me finish it here. This is equal to, let's write it here, sine of 75 degrees equal to plus square root of 1 plus cosine of 30 degrees divided by 2. And you will remember cosine of 30 degrees was root 3 over 2 divided by 2. This is not how the answer in the book is going to look like. But you can stop there. There's no problem. Okay, so let me go to number 29. These are the opposite type of problems. It says, okay, so you have this expression, 2 sine of 18 cosine of 18. Can you rewrite this thing? It says simplify the expression using a double angle formula or half angle formula. Okay, well we know that sine of 2x is 2 sine, oops. Okay, so let's go back here. Is equal to 2 sine of 2x is equal to 2 sine x cos x. So this, you look at that, so that's going to be sine of 2 times 18 degrees, and this is sine of 36 degrees. That's all you can do. That's number 29. Number 30, well, that was 29A. 29B, that was 29A. It writes something like that. 2 sine of 3 theta cosine of 3 theta. Now you have to recognize this is just like 2 sine x cos x equal to sine of 2x, right? That was the double angle formula. So this is going to be sine of 2 times 3 theta, and this is sine of 6 theta. Okay? Let's do number 30. 30a, same deal. There's an expression like that, 2 tangent of 7 degrees divided by 1 minus tangent of 7 degrees quantity square, or tangent square of that. Okay? Now let me remind you that tangent of 2x looked like this. 2 tangent of x divided by 1 minus tangent squared x. And notice that when you compare these things, x is 7 degrees. So this is equal to tangent of 2 times 7, which is equal to tangent of 14 degrees. And 13b, very similar. So 30b, not 13, 30b is really similar. It looks like that. 2 tangent of theta divided, 7 theta. Let me clean this up. Okay. 7 theta divided by 1 minus tangent squared of 7 theta. So you look at that formula that I had up there. Tangent of 2x is equal to 2 tangent of x divided by 1 minus tangent of x squared. And you notice that if you compare this thing, what you have here, your x is really 7 theta. Just look right there. X is 7 theta. So this is going to be tangent of 2 times 7 theta, and this is tangent of 14 theta. So this is the same as that. Okay, let us look at number 37. Let me start another. Okay, so let's go ahead and this is the fifth block from the top. So number 37, it says find sine of x over 2, cosine of x over 2, and tangent of x over 2 from the given expressions. So we know that 37 says sine of x equal to 3 over 5, and x we know that is between 90 degrees and 0. Okay, good. So okay, what do we want here? Sine of x over 2 is equal to, we have a formula for a half angle formula for sine. So for example, it looked like that, plus or minus square root of 1 minus cosine of u over 2. Well, first of all, let me make this thing. Yeah, this is the formula that I'm referring to in the book. Now notice that when you compare here, we want this is the formula that we're going to be using. So sine of x over 2 is equal to plus or minus square root of 1 minus cosine of x divided by 2. Now, sine of x, you were told that it's 3 over 5, and x is between 0 and 90 degrees. Now remember, that means you're in quadrant 1. Both sine and cosine are positive, so you draw the triangle that represents this condition. So this is the angle x. The opposite is 3. The hypotenuse is 5, so this must be 4, and therefore, uh, uh, let me see for a second. Okay, so cosine of x from this drawing is over 4 over 5. Yep, 4 over 5, and it is, incidentally, it is positive. And sine of half the angle, if the angle x is in the first quadrant, and that's what we agreed on right here, x over 2 is also in the first quadrant, so the algebraic sign of it is plus. So because x over 2 is also in quadrant 1. X is in quadrant 1, half of it is also in quadrant 1. So the algebraic sign of it is plus square root of 1 minus 4 over 5 over 2. The answer in the back is not going to be like this. The answer in the back probably will be square root of 1 over, I would say, 10, right? Yeah, 1 over 10. Good. Now, let's do cosine. Now, cosine of x over 2, when you look at the formula that we have for half angle, so it's going to be also plus or minus square root of 1 plus cosine of x divided by 2. And once again, because x is in quadrant 1, x over 2 is also in quadrant 1. Therefore, the cosine x over 2 must be positive. So you don't take the negative sign, so cosine of x over 2 equal to square root of 1 plus cosine of x over 2. We already got cosine of x, so 1 plus, what was it? It was 4 over 5 divided by 2, and probably the answer in the back is going to be 9 over 10. Or 3 over root 10. One or the other, I don't know. Last one from this problem. This is still number 37. Tangent of x over 2. This is no big deal. So tangent of x over 2 is sine of x over 2 divided by cosine of x over 2. And we can just plug in the value that you got. Sine of x over 2 was given to you. It was 3 over 5. Cosine of x over 2, we just worked it. I'm sorry, sine of x over 2, we calculated, it was 4 over 5. This was 4 over 5. And over here, is that what I got? No. There it is. Root of what? This is wrong. We just did this, right? It came out to be 1 over root 10. And this one is right up here, 3 over root 10. And this is 1/3. Hopefully I didn't make a mistake. I don't think so. Okay, so let's go and do the next one, which is number 38. Let me go here. we are told that cosine of x is equal to minus 4 over 5, and x, we are told that is between 180 and 270. 180 degrees and 270 degrees. First of all, let's find out where that thing is. So 180 and 270 is right here, okay, right there. So just remember that. We are asked to find sine of x over 2. Okay, now this is, just look at your formula, plus or minus square root of 1 minus cosine of x divided by 2. Okay, so this is plus or minus square root of 1 minus 4 over 5 divided by 2. I still have to pick between the plus and minus which one, so let me write it anyway. Plus or minus, we still don't know which one of these two signs is. So if you do this, it's going to be root of 9 over 10. So, question: is it plus or is it minus? Now this is where we have to look at our situation. Now, if your angle is here, just look at it here. Anywhere there, angle x is between angle x over 2 is between uh, 0 and 180 for sure. Let me give you an example. Let's pick an angle here. So how about, for example, I don't know, maybe just as an example, 200. Half of that is going to be 100. So notice that if you have an angle here, if you have an angle like that, you take half of that, you're going to end up in these segments. Okay, so the sine of it, half of the angle is going to end up either in this quadrant or that quadrant. Okay, as a matter of fact, you'll never end up here. Okay, so let's see. You only end up in this quadrant. Let me clean this up. Okay, this has to be done properly. Okay, so let's go ahead and look at it carefully. Okay, there we are. You're told that x is there. This is where x is. Okay, if I look at that, and I divide both sides by 2, so we get x over 2 is between 135 bigger than 90. Where is 135 and bigger than 90? That means that you're here, bigger than 90 and less than 135. So you are right there. So x over 2 is in this red cross-hatched area. Therefore, look at the algebraic sign of it is positive. Is between 90 degrees and 135 degrees. Therefore, sine of x over 2 is positive. This is equal to root of 9 over 10. Okay? All right, let's do the cosine. Cosine of x over 2. Now notice that based on the discussion that we had, cosine of x over 2 is negative because just look at where you end up. You end up in this cross-hatched area, right? You end up in this red area, and cosine there is negative. So first of all, above argument means that x is less than 135, bigger than 90, tells you that cosine of x over, this is x over 2, is negative. Okay? So Cosine of x over 2, use your half angle formula. It's plus or minus. Look it up in the table that you got. 1 plus cosine of x divided by 2. And this, we should take the negative because of what I just said. That means, let me write it here. Cosine of x over 2 is negative square root of 1 plus cosine of x over 2. Now let's plug in whatever is given to you. Cosine of x was given as, the problem says, right, where is the problem? That particular problem said, this was, which problem was that? This was, uh, 38, number 38. It says cosine of x equal to minus 4 over 5. Minus 4 over 5, right? Yeah, right there, right there, right there. Okay, minus 4 over 5. So just plug it in. I lost track of where I actually, okay. Let me get through this. I don't know. So it's going to be minus 1 plus minus 4 over 5 divided by 2. And if you looked at the answer in the book, it'll probably look like this, minus root of 1 over 10. Do the other arithmetic, please. Make sure you can get it. Let me do, for this is still number 38. We want to find the tangent now. Better clean this up. Okay, we're doing number 38. I'm gonna have to, this is stuff that I want to draw. Delete. Okay, so this is where we had. We just did cosine, so I can delete these things. This was our conclusion, as you can see. We did these. Now we're going to do tangent. Okay. If you want to do tangent of x, there's two ways to do it. You can write that this is sine of x over cosine of x. Oh, sorry, sine of x over 2 over cosine of x over 2. This is what we want to get, right? If you want to do it directly, you can do it like that. We already got sine of x over 2. Oops, can't remember what it was. Yeah, it was right here. It's right. It was right there. Okay, it was right there. So it's going to be minus root of 9 over 10. And we got the cosine that I just erased for you. Cosine was also minus, cosine of x over 2 was also minus 1 over 10. So this is root of 9 over root of 1, which is 3. This is do it directly. We can also use the formula for half angle. Tangent of x over 2, just look it up. Look it up meaning right where this is the very formula at the bottom of the page on the left side. Okay, so let's go ahead and work that out. You're going to get the same answer, of course. So that's going to be sine of x over 1 plus cosine of x, and I better get that same number. This one we worked it out. It was minus yeah, so if cosine is minus 4 over 5, that was given to us, right? Minus 4 over 5. So this is going to be 1 minus, let me write 1 plus minus 4 over 5. And if you look at the sine of x, sine of x, the problem is that we know that this our x is here, okay, which that means the sign is also negative, right? If you're there, the sign is also negative, and so that's also negative minus 3 over 5, and this is minus 3 over minus 1. Hang in there. Sign is negative. Let me see for a second. We're getting some problem here. So this is okay. Cosine was given to me and it was minus 4 over 5. I wrote it here. Okay, that's fine. And then sine on the top, is also, this sign is plus, so this is minus 3. From here I get minus 3, up here I got 3. Let's make sure that we did not make a mistake up there. Sine of x over 2 yeah, so I don't, it doesn't look like I'm getting the same answer. So let's get to the bottom of things. I would like to make sure that there are no mistake done. Cosine, this was correct. This is correct. Now let's go here. We were told that cosine of x is minus 4 over 5, so just put it in there. Now, what is sine of x? Sine of x is, because you are in this region, sine of x is also negative. Okay. This is minus 3 divided by 1, and tangent of x is negative. Okay, this is, oh yeah, that's okay. All right, wait a minute. Tangent of x, in fact, must be negative, so I must have done an algebra error right here. There's a problem right there. You can see that. There's a problem right there because x over 2 is in that red region. If it's in red region, the tangent of it must be negative, right? So where did I make a mistake? Let's make sure that we can figure this out. Right there. You see this? Right there. You see this? This cannot be negative. This is positive. Right there. Right there. Okay? And that whole thing becomes negative, and that agrees with what we got there. Listen, folks, this is why it's important you always look at what you're doing in a deeper way, in a sense that do it several different ways. Do you get the same answer? As a matter of fact, one possibility is that you actually take an angle here, just literally take an angle. I don't know, maybe 200 degrees, and then put it in your calculator. See whether the tangent of half of 200 degrees, is it positive or is it negative? All right, this is all sorted out. I'm really sorry about this. It's just that because these pages get messed up, I didn't realize that this was a positive, so accidentally took a negative number. Everything got screwed up.